Okay. We're going to start chapter 12 today in order to illustrate some of the concepts we're going to do in activity as we go. You're going to be measuring things today with, obviously, the ruler just gave you. We're going to be measuring in millimeters. Does everyone know how to measure things in millimeters? So there are 10 millimeters and 1 centimeter. Everyone with me? Yes? Okay. So I'm going to have you measure stuff, but the first thing we're going to do when I do the activity in a second, you're going to have to make an estimate in millimeters so you're not actually measuring anything. So just kind of look at the ruler for a second and make sure you kind of know what maybe 10 millimeters looks like, because we need to make an estimate off the fly using millimeters. I know you don't measure in millimeters very often, so kind of familiarize yourself with how much that is. 10 millimeters is 1 centimeter. Yeah. Okay. So I'm going to put a piece of paper face down on your desk because I want you to have to make an estimate without you staring at it the entire day first. So I'm going to put one of the pre-calculus formula sheets over top so that you're not staring through the paper as well. Do not look at the paper until I tell you to. I don't know. People did not follow the directions this morning. Just don't look at it until I tell you. It's not like it's a big deal. I'm just trying to get you to make an estimate later, and it won't be as accurate if you're staring at it for 10 minutes before we do it. So just don't look at it. Okay. Okay. I know this is super lame. I stole things off the internet again. So the premise is lame, but it's better than the secondary option. So just go with me here. Okay. So no, you can't plagiarize. This is like a shared activity. All right. So I'm going to tell you what's on the back of the paper. I just don't want you to look at it yet. Okay. On the back of the paper is a colony of quote-unquote jelly blubbers. They're like jellyfish-looking things that aren't really jellyfish things. So, jelly blubbers. Listen, the alternative is looking at a bunch of rectangles, and that's no fun. Okay? So, jelly blubbers. Okay? Their body is made up of an oval. Okay? So, there are 100 jelly blubbers on the back of this paper that you're not looking at it yet. Okay? So, we're going to talk about different methods of sampling today. All right? And we're going to try to make some estimates here. But so, we're going to be measuring the width horizontally, because all the ovals are laid out horizontally, okay? So we're measuring the width of the jelly blubbers, okay? So in a second, this is going to be your task. In a second, I'm going to say that you can flip this over, not yet, but in a second I'm going to say flip it over, and you're going to have approximately 5 seconds to look at said colony of jelly blubbers, and then tell me afterwards how wide do you think they are on average. Okay, so it's just an estimate. You're gonna eyeball it in millimeters. Okay? Does everyone understand the directions? So you don't need to measure anything. You're just gonna flip it over. I'm gonna give you 5 seconds, and then you're going to give me an average of how wide they are. Okay? So yeah. So I'm gonna tell you when to flip it. Ready? 1, 2, 3, go. Oh my God! They're so cute. Yes. All right, flip them back over. I told you to give me 5 seconds. 40. All right, so in your mind, get a number. I'm going to add this to the dot plot from first period because there's only 10 of you, and so we'll make sure we have enough data. Okay? Okay, I'm going to go one at a time. You're just going to tell me in millimeters how wide do you think they are on average? Men. 30. Okay. Clay. Jacob. Okay. Peyton. That's with first period. So, if we're looking at this, it's fine. Totally fine. We're totally just eyeballed this. wasn't exact. Okay? So, if you're looking at this, then what would we say about the shape and center and spread of this dot plot? Unimodal. I mean, it's almost like symmetric. It's just really spread out, right? There's just not a lot of data for each point. You should say it's spread out. Yeah. Okay, so we've all seen this. All right, so let's talk about some definitions. All right, because again, I'm introducing things from chapter 12. So generally, when you're doing a sample or doing, especially here, we're talking about sample surveys all the time. If you're doing a sample, you have an entire population that you're concerned about. So in this case, we're concerned about the entire population of jelly blubbers, okay? And then we want to take a sample to see how wide they are, all right? Just like if you're doing a poll, like it's election season, so you'll hear a lot about poll results and stuff. Well, if you're thinking about, for example, say the Republican primary or the Democratic primary, doesn't really matter which, right? They say there's some poll results. They can't actually go out and ask every single Democrat and every single Republican, okay? So they're using a sample. So your population would have been the entire party, and the sample is who actually got asked these questions, okay? So you can do the same thing when we're doing these jelly blubbers today. We're going to be talking about different methods of sampling, and then we'll actually continue that a little bit tomorrow with some more examples. All right, so everyone understands population and then a sample. Those words, we got that. So I'm going to ask you to do something else this time. So you can flip your jelly blubbers back over. You can look at them and stare at them. All right. This time I'm going to ask you to do something a little bit different. This time we're actually going to be measuring. All right, so listen to the directions before you do anything. I'm asking each one of you to select 10 jelly blubbers that are representative of the population, and then you're going to measure those 10 and then take the average and tell me your average. So this time you're using 10 that you think are representative. So you need to select 10, measure the 10, and then average those 10 lengths. You decide what representative means, and we'll talk about it afterwards.
For the smallest one. Maybe not the
Okay. Here is data from first and fourth period. Fourth period is in purple.
Whoever's average is 40, they obviously only measured the distance.
So, yes, let's talk about what representative means. Representative means you need to have some of each size. Representative means you do not need to pick all of the large ones. That's not representative of the population. That's like me trying to survey 20 people at school, like just 20 people, and picking 20 seniors and not picking anyone else. So you need to make sure we all know what representative means. We know what representative means. Yes? That representative means that you've selected some from like each side. Like represents the entire population as a whole. I don't know what it means. Pick the one that looks the best. I don't know what that means.
Okay, 52 is pretty good. Did you pick 52?
Anyway, okay, so let's talk some more about some things. Chapter 12 stuff. The problem with that method that I just had you do, picking out representative ones, is sometimes things can become biased very quickly. So those of you that picked out, there was someone definitely in first period, and I think some of you guys in here picked out just the large ones. That is overemphasizing the large ones, right? The entire population is not made up of those large jelly blubbers, all right? But so now you've overemphasized that, and you've made the sample seem like that's what their size is, but it's really not, okay? This becomes more of a problem when you're talking about people, all right? So we're talking about sample surveys, like polls and things, like whatever. If I send you guys all out with like survey questions, all right, and I tell you to go talk to 15 people in our school building, all right, you guys are more than likely going to start asking people you already know, and so those people may or may not be representative of the entire school population, okay? So it becomes a lot more tricky when you involve like a human element to it. Like picking the jelly blubbers is not a big deal, right? It's just a piece of paper, you pick some out. If you start talking about people, though, you're going to talk to people that you already know, already talk to on a regular basis, okay? And that's become biased because, again, what if I was talking about the survey had to do with school activities? I can guarantee the people you already talked to are all in the same activities that you are. So that is not going to be representative of the entire school population. Does that make sense? So be careful of things being biased. So in order to remove bias, because sometimes there are even underlying things we aren't aware of, okay, we want to use randomization when we do any type of survey. We always want to randomize somehow, some way, all right? So you're going to take your entire population and you're going to somehow randomize it so you select so many people at random for your survey. So if I was sending you guys all out to ask survey questions, I'd probably get the entire school roster and I would number them all, and you would select 15 at random with your random number generator, and you'd have to go ask those people, okay? It wouldn't just be like you picked them because you felt like it, okay? So we're going to do jelly blubbers one more time. This time we're going to employ randomness to see what happens. So all of your jelly blubbers are numbered 1 to 100 on your sheet. So you're going to use your graphing calculator to select 10 between 1 and 100. You're going to measure those 10 and then average them and give me how large they are. Okay. Yep. Okay, so here is our dot plot from using 10 chosen at random. So if you notice, when we did a representative sample, despite people that don't know what representative means, it was really tight and compact and it was unimodal symmetric, right? Here it's a lot less compact. And that's actually to be expected, okay? If you're going to choose at random, right, we're hoping that random is representative, but anything can happen, right? Anything can happen once, right? Just like we talked about simulations in Chapter 11, you can get those 3 varsity athletes in that dorm room. It could happen. It won't happen very often, but it could happen, right? Same thing here. You could choose 10 random digits, and you could get all of the little tiny, teeny little blubbers, right? You could get 10 of the really large ones, okay? So we call that sampling error, and sampling error sounds bad, right? But so we also call it sampling variability. That sounds better, right? It just, yes, sampling error and sampling variability are the same thing. So it just means that from sample to sample, different things are going to happen, all right? So after Christmas, all this stuff we've been doing, we're going to start taking results, and we're going to be able to use results and actually do tests and like talk about how significant those results are, etc. But so after Christmas, we're going to do some confidence intervals, and a confidence interval has a margin of error. So it's going to say, like if we were doing jelly blubbers, the width of the jelly blubber is approximately this, plus or minus this, right? We're never going to be 100% exact on any of our measurements or any of our survey results or anything. It's just not going to happen, right? Every survey would be different. If I gave this class and my first period the same set of questions, okay, and they were quantitative questions, all right, and I sent you guys out, and it was just a survey for seniors. So we took the entire senior class, and we numbered them all, and you guys selected 25 at random. Every single one of your survey results would be different. It just would, all right? It just that's what happens, okay? So you have to expect sampling variability, and this also shows that if you're selecting, that it might be on this activity more exact, but in real life, it's going to be probably more biased, okay, because of who you're selecting, okay? So, does that make sense?
Yeah.
All right. Then the last thing I want to mention is that your sample size really doesn't really super matter. So there was 100 jelly blubbers on the page. You don't necessarily have to have a certain fraction of an amount, okay? It just needs to be representative, okay? When we start doing a bunch of tests and things after Christmas, there's always a set of conditions that have to be met, and those conditions are going to include like a sample size condition. It doesn't say it has to be exact, it says it has to be greater than this amount. It'll depend on your actual population size and some other things, okay? So it's not going to ever be really an exact science. You just need to make sure that you have representative value. So probably 5 would have been too small because there's more than 5 different sizes of blubbers, right? But like you didn't need to do 25 of them to get a sample. 10 is 10%, I mean that's pretty good. You would expect 100 students or 100 voters to probably represent an entire like group of voters in a certain population, even though it's just 100, probably have the same sort of opinions. So you don't have to worry about getting an exact sample size or an exact science for your sample size, as long as it's going to be representative. And then the last thing is doing a census. All right, we all heard of a census. A census means that you survey everybody. So in this case, we could do a census of the jelly blubbers. There's only 100 of them. But someone already said it was tedious to do 10, right? So think about how long it would take you to measure all 100. It would take you a really long time, okay? So here are some things that make a census maybe a bad idea. It's difficult to complete, right? Time, right? Effort, that kind of thing. If you're talking about an actual population of people, like let's say I wanted to do a survey of every single senior in high school in Kentucky. Well, I cannot survey every single senior high school in Kentucky at the same exact time. If I did, it have to be like online or something, and guarantee people are going to be absent or something, right? If I'm trying to do that in person and I start from West Kentucky and go to East Kentucky, I guarantee that I'll miss people because they're absent or people move, right? People are always in transition, so you will never, hardly ever get actually the population you set out to get. Does that make sense? And then it can be way more complex because you have to talk to every single person to get a set of answers, and you have lots and lots and lots of data to go through. It's madness, right? That's why the United States government doesn't do a census every single year. It would be stupid, okay? So it's a lot of, I think it's every 10, yeah. Yeah, so for U.S. Census, they send them out in the mail. Then they have people come to your door if you haven't sent it back, all this stuff. But it's craziness. Like, you have to pay those people. It takes lots of time. They're trying to get the best they can, but the U.S. Census is rarely ever actually a census of everyone in the United States. Right? It's not the entire population. It's just not feasible. It's the most people they could get. Okay? So, be careful about wanting to do a census. It's just more complicated. It just seems to be, you know, an extra effort that's not really required.
But if it's like a small group of people.
Sure. If I was going to do a survey for AP Statistics, I have 34 total students. I could do 34 students. It wouldn't be the end of the universe. Right? So, questions about things we talked about today. Population and samples, bias, randomization, sample size, census. Chapter 12. Anything about that? Okay, so then listen very carefully. Tomorrow, we're going to take a reading quiz. All right? The reading assignment is on page 273, and you're going to read to 277. Now listen to my directions. The reading assignment is about the different types of samples. All right? So there's different types of like methods to sampling, right, that employ this whole randomization strategy. Okay, there's different types. So you're going to read about them. That's pretty much the essential part of this entire chapter. So I suggest you take notes over them and you know the difference. All right. At the end of that section, there's one of those little just checking boxes, you know, the purple boxes in your textbook. And it says, here's a scenario, what kind of sampling was employed. All right. I would practice that. The answers are, again, always at the end of that section's exercises in your book. So I would practice that because that's what your reading quiz is going to be tomorrow. I'm going to give you 4 scenarios, and I'm going to give you the types of sampling, and you're going to match them up. Okay? There's 4. Well, there's 5. One of them is called multi-stage, and it just is combining any of them. So there's really 4. Okay? And then I'll also ask you a question about sampling error / sampling variability. It's also in the reading, but just make sure you know what that is. All right, so that's the 5 questions tomorrow. I've already told you what's going to be on it. Okay? Also, just so we're all on the same page, we'll go over that a little bit after your reading quiz tomorrow. Then I'm going to go through the end of chapter 12, which there's not much left, but we'll talk about the different types of bias. There's different types of sampling. There's different types of bias. All right? So it's just more definitions. And so we're going to have a quiz over chapter 12 on Friday. We'll work on some stuff on Thursday in class, but all it really is definitions. So if you look at an AP multiple choice question from this chapter, it's going to say, here's a scenario. What type of sample was done? So really this whole entire chapter boils down to, do you know the definitions or not? So if you don't know the definitions, it will not be good. That's why I'm saying you might want to take notes and go ahead and have them. If you have questions about them, I will answer your question. I'm not going to teach them to you tomorrow before the quiz. If you have a question about them, I will answer them individually tomorrow before the reading quiz. Okay? We all good?
One question before